You are surrounded, at this very moment, by things that can kill you, and they are not the things you imagine, not fire, not a blade, not a fall from a great height. I spent my life handling one of the most dangerous substances ever discovered, a substance I pulled from tons of raw ore with my own cracked and bleeding hands, and I did not know it was killing me until it was far too late. That substance now bears my name as a unit of measurement, the Curie, the standard by which we count the disintegrations of radioactive atoms. But the measurement came after the damage, and it always does. Most people, when they think of danger, think of what is visible, and that is the first mistake. For many, it turns out to be the last one they ever correct. Let me tell you what I learned about invisible things, because I believe it will change the way you move through every room you enter from this point forward. There is an assumption most people carry so deeply they have never once examined it. The assumption is that if something is dangerous, you will know. Your senses will warn you. You will see it, or smell it, or feel pain, and you will move away. This is how animals survive, after all. The hand pulls back from the hot stove, and the nose recoils from spoiled meat. We trust our senses because for most of human history, they were sufficient. But consider what that really means. Your entire model of safety rests on the range of your perception, and your perception is extraordinarily narrow. Your eyes detect a tiny sliver of the electromagnetic spectrum. Your nose is crude compared to that of a dog. Your skin cannot feel a single atom, though atoms strike it by the billions every second. You have built your sense of security on an instrument, your body, that is nearly blind to most of what exists. This is not philosophy. This is measurement, and this is fact. When I began my work at the Sorbonne at the close of the 19th century, the scientific world had just received a shock. Wilhelm Röntgen had discovered a new kind of ray, invisible and penetrating, capable of passing through flesh and wood and paper as if they were not there. He called them X-rays because he did not know what they were. You may have seen the photographs, the bones of a living hand visible through the skin, and the world was astonished by them. But I want you to notice something about that astonishment. People were amazed by what the rays could reveal, and almost no one asked what the rays might do to the hand. That is the pattern, and that is always the pattern with invisible things. We marvel at their usefulness and forget to ask about their cost. Shortly after Röntgen's discovery, Henri Becquerel made an observation that would alter the course of my life, and I believe the course of human understanding. He found that uranium salts emitted rays spontaneously, not because they had been exposed to light, not because energy had been added to them, but simply because of what they were. The rays came from within the atom itself. Energy was appearing from matter without any known source, and the very concept seemed to violate what most physicists believed about the conservation of energy. I chose this question for my doctoral research, becoming the first woman in France to attempt one in physics, not because the question was safe or fashionable, since it was neither, but because it was unexplained. Unexplained things have always seemed to me the most worthy of attention. My husband Pierre agreed, and we understood, both of us, that the most important work is often the work that others have not yet thought to do. I began by measuring, because you must always begin by measuring. The instrument I used was a piezoelectric electrometer that Pierre and his brother Jacques had designed, a beautiful device, exquisitely sensitive, capable of detecting the faintest electrical charge in the air. I exposed different substances to this instrument and recorded the ionization they produced. Uranium came first, then thorium, then compound after compound. That systematic precision, the first of its kind applied to radioactivity, led me to something that should not have been possible. The substance was pitchblende, the heavy black ore from which uranium is extracted, mined for centuries in the Joachimsthal mines of Bohemia. And the radioactivity of the pitchblende was stronger than the radioactivity of pure uranium itself. Think about what that means. The raw ore was more active than the refined element. This was like saying a mixture is purer than its purest ingredient, which made no sense unless there was something else hiding in that ore, something unknown, something more powerfully radioactive than uranium itself. That moment of realization, that quiet moment in our laboratory at the Sorbonne, where we worked in a converted shed with a leaking glass roof and a dirt floor, rearranged everything. There was a new element in that ore, perhaps two elements no one had ever detected and no one had ever seen, because their presence was betrayed only by invisible rays that no human sense could perceive. I named the first one polonium, for the country of my birth, which at that time did not exist on any map, because it had been partitioned and occupied by 3 empires. The second we called radium, because of the extraordinary intensity of its radiation. Both had been there all along, embedded in the earth, radiating ceaselessly for millennia, entirely unknown. And this is the first thing everyone gets wrong about invisible dangers. People assume that if something dangerous existed near them, it would have been found already, that someone would have noticed. But you cannot notice what you have no instrument to detect. For all of human history, people lived beside uranium ore and felt nothing. Miners worked the Joachimsthal tunnels for centuries, sickened and died young of a wasting lung disease they called Bergkrankheit, meaning mountain sickness, and no one understood why. The cause was invisible, and they had no means to make it visible. We now know those mines were saturated with radon gas, a direct decay product of radium. The very element I was isolating in my laboratory was producing, through its steady atomic disintegration, the invisible gas that had been killing miners for 400 years. Consider that connection for a moment. A discovery in a Paris shed and the deaths in Bohemian mines centuries earlier, linked by an element that no one knew existed, producing a gas that no one could see. Pierre and I spent 4 years isolating what was hidden in that pitchblende, and those 4 years demanded physical labor I can only describe as crushing. We processed tons of ore by hand, boiling it in cast iron cauldrons, filtering, precipitating, crystallizing, stirring vats of liquid with iron rods nearly as tall as I was. The work was not romantic. My hands cracked and bled from the chemicals, and the labor resembled that of a factory far more than a lecture hall. But here is what I want you to understand. During all of that work, we were being irradiated, constantly. The substances we handled emitted rays that passed through our clothing, through our skin, into our bodies every hour of every day, and we did not know. We could not know, because the damage radiation does is not immediate. It is cumulative and patient. It works at the level of what we would now call the DNA molecule itself, the instructions within your cells that govern how they grow, divide, and repair. And it does so without announcing itself. Pierre noticed something early on. He strapped a small tube of radium to his arm for 10 hours, deliberately, as an experiment, and the skin beneath it reddened, then blistered, then formed a wound that took more than a month to heal and left a permanent scar. He documented this with the same precision we applied to everything. Becquerel had a similar experience after carrying a tube in his waistcoat pocket and receiving a burn that astonished him. These were our first warnings, and even then, I must confess, we did not fully appreciate their significance. We described these effects in our publications and reported them to the Académie des Sciences. But understanding requires time, and time is precisely what invisible dangers steal from you while you are still trying to comprehend them. That brings me to the second thing people get wrong. They believe that once a danger is identified, it is understood, and it is not. Identification is only the beginning. Let me make this concrete, because this is where most explanations fail you. If you swallow a speck of radium, a particle no larger than a grain of dust, your body mistakes it for calcium because the two share similar chemical properties. Your body does what it always does with calcium and deposits it in your bones, and there it sits, lodged in your skeleton, firing alpha particles into the marrow that manufactures your blood. Alpha particles are heavy and slow, stopped by a single sheet of paper, which means they cannot penetrate your skin from outside. But from inside your bones, at point-blank range, they are devastating, tearing through the delicate machinery of cells the way a stone tears through wet paper. This is what happened to the dial painters, and this is what was happening, invisibly, inside my own body. Beta particles behave differently, lighter and faster, carrying enough energy to penetrate skin and damage tissue from outside. And then there are gamma rays, which are massless and travel at the speed of light, capable of passing through lead, through concrete, through you. As a gamma ray passes through your hand, it knocks electrons from your atoms and shatters the molecular bonds holding together the instructions of your cells, the very structure of your DNA. You feel none of it. Your hand looks the same, and your fingers work perfectly. But inside, at a level you cannot perceive, bonds have been broken that your body must now repair. And if those bonds break often enough, or in precisely the wrong place within the genetic instructions, the repair fails, and the cell becomes something that grows without restraint, which is what we call cancer. Think about what that means for your understanding of danger. You are accustomed to a world where harm and awareness of harm arrive together. You touch the hot stove, you feel pain, you pull away. The feedback is immediate. But with radiation, the feedback is delayed by months, years, sometimes decades. The exposure happens on an ordinary Tuesday while you are working and thinking of dinner, and the consequence arrives years later in a doctor's office with no apparent connection to that Tuesday at all. This is, I believe, the deepest challenge invisible dangers pose to the human mind. The challenge is not that they are hidden, because we can build instruments to detect them. And it is not that they are powerful, because we can build shielding to block them. The deepest challenge is that they sever the connection between cause and effect. They break the link your mind relies on to navigate the world safely, and once that link is broken, your intuition becomes not merely useless but actively misleading. The old physician Paracelsus understood a version of this 5 centuries ago when he wrote that the dose makes the poison, that nothing is inherently safe or inherently lethal, but only more or less dangerous at different quantities. Radiation taught me just how right he was and how poorly human intuition grasps it. I named the phenomenon. I studied radioactivity, and I chose this word deliberately. It describes what the atom does, which is emit rays, rather than what the atom is. When you are studying something genuinely new, you must resist the urge to explain it before you have finished measuring it. Name the behavior, then measure the behavior, and explanation will follow, but only if your measurements are honest. This discipline, this refusal to leap ahead of the evidence, was recognized by the Nobel Committee in Stockholm, first in physics in 1903 for the work on radioactivity alongside Pierre and Becquerel, and again in chemistry in 1911 for the isolation of radium and polonium. I mention these not from vanity, but because they represent something important. The scientific community acknowledged that measuring invisible things with precision was itself a contribution to human knowledge, not just the discovery, but the measurement. People have asked me over the years whether I was afraid, whether I worried about the materials I handled. In those early years, we did not know enough to be afraid in the way you might think. We took some precautions and understood that the rays could burn skin, but the full biological consequences, the slow erosion of blood-forming cells, the accumulation of damage to genetic material, the patient progression toward leukemia, none of that was yet understood. We were, in a sense, the experiment. Our bodies became the evidence that would later inform the safety measures others would use. My personal notebooks from those years remain so contaminated with radium-226 that they are stored in lead-lined boxes at the Bibliothèque Nationale de France, and anyone who wishes to read them must wear protective clothing and sign a liability waiver. A full century later, the pages I touched are still radioactive, and they will remain so for another 1600 years. Let that settle in your mind. The danger has outlasted me, and it will outlast the building that stores my notebooks, and it will outlast everyone listening to this. Here is the part of this story that I think is most important and most widely misunderstood. The invisible danger of radiation did not diminish the value of what we discovered. It complicated it, and there is a difference between those two things. When people learn of the dangers Pierre and I faced, they often respond with horror, as though the danger negated the work, as though we were foolish. But consider what radioactivity has made possible. I personally helped develop mobile X-ray units during the First World War, driving them to field hospitals near the front lines so surgeons could locate shrapnel and bullets inside wounded soldiers. That same invisible energy now enables the imaging of bones and organs without surgery, the treatment of cancer through targeted radiation, the understanding of atomic structure that underpins all of modern physics and chemistry, the generation of electrical power, and the tracing of biological processes within living systems using radioactive markers. All of it grew from a phenomenon that is, by its nature, invisible and dangerous. The danger is real. The value is also real. These two truths exist at the same time, and you must hold them both without allowing either to eclipse the other. But the lesson extends far beyond my laboratory. You live right now in a world dense with invisible agents whose dangers you accept without thought or reject without evidence. Radon gas, that same decay product of radium I described earlier, seeps from the ground into basements and foundations and ranks as the second leading cause of lung cancer, yet most people have never tested for it. Ultraviolet radiation from the sun cannot be seen and cannot be felt until the burn has already occurred, and by then the damage to your skin cells' DNA is done. Ionizing radiation reaches you from medical imaging, from air travel at high altitude, from the natural radioactivity of the granite in public buildings, the thorium in old camera lenses, and the phosphate fertilizers spread across farmland. Background radiation is striking your body at this very moment, and cosmic rays that have traveled across the entire universe are passing through you this second. You feel none of it, and for the most part at natural background levels the risk is very small, but it is never zero. That is the third thing people get wrong. They think in categories, dangerous or safe, harmful or harmless, but invisible dangers do not respect categories. They obey doses, accumulations, and probabilities. A single chest X-ray delivers roughly 1/10 of a millisievert, which is the unit we now use to quantify biological risk from radiation. A full year of natural background exposure delivers about 2 to 3 millisieverts, and a CT scan delivers perhaps 10. The question is never whether something is safe, but rather how much, for how long, and at what probability of harm at a given dose. This way of thinking, quantitative and patient and unsatisfied with simple answers, is what the study of radioactivity taught me more than any other single lesson. The world is not divided into dangerous things and safe things. It is a continuum of exposures, and your task, always, is to measure. I spent my life measuring. After Pierre was killed, struck by a horse-drawn wagon on a rain-slicked street in Paris, a visible danger and the most brutal and ordinary kind, I continued the work alone. The work was not finished, and the phenomena we had uncovered demanded understanding rather than abandonment. Measurement is an act of respect toward the truth, and the truth does not care whether you are grieving. My later years were devoted to establishing standards for the measurement of radioactivity, standards that allowed scientists and physicians worldwide to speak a common language of dose and risk. This matters more than any individual discovery, because standards transform private knowledge into public safety. What was once invisible becomes countable, and what is countable becomes controllable. Not safe, but controllable, and there is an important distinction between those two words. You cannot make radiation safe, you cannot make radon safe, and you cannot make ultraviolet light safe. You can measure them, contain them, reduce your exposure, and make informed decisions. And that is enough if you are honest about what you are dealing with. I think now of the young women who worked in factories in New Jersey and Connecticut, painting watch dials with radium-infused paint so the numbers would glow in the dark. History remembers them as the Radium Girls. They were told the paint was harmless, and the United States Radium Corporation instructed them to lick their brushes to make fine points. They painted radium on their fingernails for amusement and on their teeth to make their smiles glow at dances. And then they sickened, their bones growing so brittle they shattered, their jaws disintegrating. They had become, without knowledge or consent, subjects in an experiment whose results arrived years too late to save them. Some of their graves, exhumed decades later, still registered on Geiger counters, because the radium in their bones was still decaying, still emitting, still dangerous. Long after the women and the company that poisoned them and the doctors who examined them had all passed from living memory. This is what invisible danger does when paired with ignorance, and not only the malicious kind, though that existed too, but the simple and common ignorance of not knowing what you have not yet discovered. Those women were not foolish. They had no instrument, no standard, no framework to detect what was happening inside their own bodies. Building that framework requires exactly the kind of slow and painstaking measurement that most people find tedious and most institutions find expensive. The greatest danger of invisible dangers is not the damage they do to your body, but the damage they do to your thinking. They tempt you into one of two errors, and both are fatal to clear understanding. The first error is denial, where you cannot see the danger, so you behave as though it does not exist. The second is panic, where you cannot see the danger, so you imagine it everywhere, in everything, at every dose, and you become paralyzed. Both errors grow from the same root, which is the human craving for certainty. You want to know that you are safe, or you want to know that you are doomed, and you do not want to hear that you exist in a state of probabilistic risk, depending on dose, duration, shielding, and a dozen other variables you must measure and evaluate continuously. But that is the truth, and that is always the truth with invisible things. Every generation discovers invisible dangers the previous generation did not know existed. Lead in paint and gasoline, asbestos woven into walls and ceilings and brake pads. The microscopic particles from tobacco smoke, whose danger was invisible, not because the smoke itself could not be seen, since you could see it plainly, but because the mechanism of harm was hidden, delayed, statistical, and deliberately obscured by those who profited from the ignorance. The pattern repeats and will always repeat, because the universe contains more than your senses can detect, and each new instrument, each new measurement reveals both wonders and hazards that were always present and always acting upon you, waiting only to be discovered. What I want you to carry from this, what I hope you will hold long after you have finished listening, is not fear. Fear is useless against invisible things, because fear makes you close your eyes, and closing your eyes does not make the unseen any safer, but only makes it more dangerous. What I want you to carry is a habit, the habit of asking what you are not perceiving, what is present in this room, this substance, this process that your senses cannot detect, and then finding the means to measure it. An instrument, a test, a study, a question put to someone who has spent their life measuring what you have not. This is what science is at its most fundamental. It is the extension of human perception beyond human senses, and the refusal to accept that what you can see is all there is. Every instrument I ever used, the piezoelectric electrometer, the spectroscope, the ionization chamber, each one was an admission that my eyes and hands were not enough, that the world is larger and more complex and more dangerous and more beautiful than any single human being can perceive unaided. That is what invisible danger really teaches you. Not that the world is more frightening than you believed, but that the world is more than you believed, more real, more intricate, more worthy of the most careful attention you can give it. The invisible things, the rays, the particles, the silent processes working at the level of atoms and the molecules of life, they are not aberrations, but the fabric of reality itself. Most of what exists is invisible to you, and it always has been, and it always will be. The only question is whether you will have the patience and the honesty to measure what you cannot see, and the courage to act on what the measurement reveals. That is all any of us can do, and that is all I ever did. And I will tell you, with the full weight of a life spent in the company of invisible things, that it is enough